Welcome to exam 4 text corrections. The first problem I wanted to go over was problem number 2. It says two parallel lines are near each other and they carry currents in the same direction. Wire 1 carries a current 1 and wire 2, I, and then current 2 is 2I. Which statement about the magnetic forces that the two wires exert on each other is correct? I said F because it says wire 2 exerts a stronger force on wire 1 exerts on wire 2, and they attract each other. The correct answer is B, which is the two wires exert an attractive force of the same magnitude on each other. So what I wrote here is that using the right-hand rule, if each current is going the same direction, then the magnetic fields are also in the same direction and the forces are towards each other. And the next problem I wanted to go over was problem number 3. It says an inductor and a resistor are connected in series to a battery. There's a switch that allows the current to be opened and closed. At the instant the switch is closed, the voltage drop across the resistor and the inductor maximum. The correct answer is the inductor. So basically, I wrote the voltage drop across the inductor will be at maximum. This is because the most current will be crossing the inductor at that time. As the time goes on, the current through the resistor will have more voltage drop and the inductor will have less. And I looked up a graph so you could visually see it. So as you can see, the inductance is going to be at the max at the beginning, and then over time they switch places. Alright, the next problem is number 5. This says if the current in an inductor is cut in half, by what factor is the stored energy multiplied? And I put B. This is the equation I used, which doesn't make sense, so the real correct answer is E. And as you can see for number 5, the correct answer is E, which is 1/4, and this is the correct equation to use. And then when you put the 1/2 in there and multiply it, it turns it into 1/4. So 1/4 is the answer. The next problem that I wanted to go over was number 7. And we're trying to find the ratio of secondary to primary turns of the transformer. I did the voltage primary over secondary, which is equal to 0.02 voltage, but that doesn't really make sense. So the correct way to do it is you put the secondary over the primary, because the secondary is more, and that gives you the 50 volts. The next problem to go over is problem number 8. We're trying to find the capacitance of a capacitor charged to 15 volts and then connected across an inductor, and the maximum current in the circuit is 0.35A and the inductor is 0.18 henries. This is what I got, and I wasn't quite sure how to go through this problem, so I guess I didn't finish it. Anyways, moving on. Number 9 is the two straight parallel wires separated by 6 centimeters. The current is 2, and what we're trying to find is the magnitude and direction of the current in this second wire. So I did it very close to being correct. But what I forgot, let's see. Going over question 9. Oh, I wrote it one way and then I crossed it out because this way it made more sense to me. So basically we have the equation for the magnetic field, and we solve for the magnetic field in wire 1, and I got 1.82 times 10 to the negative 5, And then what we do is we use that and plug it in to find current 2 in the current in the second wire. So then you plug it in and you solve for that I, and then you get 3.5A. That was pretty simple, but for some reason I didn't quite get there. The next problem I went over is problem number 10. And this one we're trying to find how much current the solenoid carries if it has 765 turns of wire. Now I had the right equation, I had the right numbers. The only mistake is when instead of putting turns right here, I put the magnetic field in twice. So that should have been the 765. And yep, you plug it in right there and you get the 0.16 for the current. All right, and then problem number 11, we're trying to calculate the inductance of the coil. So you write down all of the known keys of this, pieces of this problem, and then we are given this problem in our test notes, and you solve that for T, which is the time constant, and we know that that is equal to L over R. So you solve for that, and then you times it by R, and you're going to get the inductance. So you can see here all the key parts, and then we solved it for T, and then I just plugged in everything we knew. One part that I forgot to do in this problem was instead of finding the I naught, I just put I in there. So right here, instead of putting I naught underneath that, I just used that. So that was my problem. And how you find I naught is it's going to be the voltage divided by how many turns. And that comes to be 0.24. So you plug that in right here, you solve for T, and then the inductance is T times R, so you times T by R, T by R, and you get the 0.168 henries. The next problem that I got wrong was number 12, and I understand it to the point where this is the equation and you're trying to find A, so you would take the derivative of both sides and it would get rid of the integral. And so you're given B is equal to this equation, and it's B dot A, so A dot B, and this is the derivative of B or I guess if you took the derivative, now that I'm thinking about it out loud, it would just be B dot A. Anyways, I'll have to go work through that later, but I got the numbers wrong, you know that it's going to be clockwise, because when you look at the picture, you're going to use the right hand rule, and you're going to put your hand, your fingers in the direction curling up into the loop, and your finger or your thumb is pointed off to the left, which means the current is going up through the loop in a clockwise direction. It's kind of hard to tell when you're looking from above, but just know that the current is going up and over. And that concludes my test corrections.